50 minutes on how containers are making your life possibly worse, or definitely worse, and then some things that are going through about how it is making your life better. So let's start with me. So I'm Steve Poole. I work for IBM, I think. I'm a developer advocate, but what that means is I mostly have been a developer for a long time on JVMs and stuff like that. And I've done development tooling and all sorts of bits and pieces. And I got to the point where I got old enough for IBM to say, you can go off and talk about stuff. So most of the time, I come off and talk about stuff that's happening, the stuff that interests me. And one of the things that really interests me is this whole container space. And so we're going to talk through, eventually, I want to talk through 3 things that are going on. I want to talk about what's happening at the platform, what's happening for the runtimes. So this will be a JVM focus, because that's what I do. And then a little bit, we'll talk about developer experience and what's happening in those spaces. And this is all container-based, okay? Because at the end of the day, before we get to talk about the stuff and the good stuff, we should talk about where we are, right? So, cloud. It's what everybody wanted. We signed up for cloud. Compute on tap, soon as possible, please. Infinite scalability, you know what it's like. Yeah, cloud, great. But it's not really cloud, is it? It's containers. It's all about containers, right? Everybody does containers because you can put something in a box and take it wherever you want. You can do anything with the containers. These are real containers that people live in, which I suspect is quite cold because they're made of metal. But there we go, right? And you can build things with them. These are real containers turned into artwork. Literally, people have joined them together. Okay, that's what you can do with containers. And by putting all these containers together, we know we can go off and build these fantastic opportunities, new things. The world has sold into this. All of the businesses have said, that's the way forward. We understand. Go make it happen. So as long as the answer is container, we're done, right? No problem at all. Why? Why have we picked containers? Because of 2 little words, immutability and repeatability. This idea that we can bake something in and it will always behave the same way, and we can scale things because we have a building block that behaves and it scales, right? And we went, this is really good because not only does it give us repeatability and mutability at scale, which is what we want, we can take out those old big things that we used to have that would stand up forever and run around but were a bit slow and a bit old, and swap them for something that didn't live so long but which we had a lot more of. That was the plan. Okay? And to start off, we thought that was good. If any of you were around when we first started doing containers, we went, this is easy. Get my code, compile it, build a Docker file from it, push it to the registry, done. The development process can pick up my container and test it and do whatever they want and put it into production. And that's what we thought. And if any of you are doing this, you know that's not the case. We know that actually if you take a container and try to put it in production, the developer created, there will be a whole list of things that are actually wrong with it in terms of content, security issues, oh, it's a bit too big, a bit too fat. There's a whole bunch of things which mean that we don't do that anymore. Okay, so cloud computing is not perfectly perfect. There are a few raindrops. Okay, let's explore a few of those. So this is a common tale, which I think I've sort of said about. There's your local environment. You know what it is? You've made choices about what platform you've got and what your build processes are and whether you're using Git or whatever, and you're doing Maven or Gradle or whatever it is. And you run that locally, and you use Docker locally, and then you probably have a build server, which is probably Jenkins, something like that, and that has a bunch of stages where it's doing very similar things but with different tools. And it's probably got somewhere in there, it's probably got a Kubernetes in there somewhere, and then eventually you push it out to big cube. Okay? We know quite often, in fact very often, that as a developer, what you build there, doesn't necessarily match what came out of the containers that were built during the test process for a whole bunch of reasons, like build tools not matching, and then the needs to have different content. And then, of course, what you actually end up pushing and running is, of course, not exactly anything like what you thought you started off with. So the consequence is if you talk to people who are doing this a lot, and I'm going to ask you in a minute, is quite often the thing that this thing that we said to ourselves about containers, which was that it was going to be mutable and scalable and those wonderful things, is turning out not to be as good as we thought because of this process that we've created. And that at the end of the day, we end up quite often with containers not having what we thought, not working the way we thought. And then when they do go wrong, incredibly hard to debug. Debugging your application through a tiny letterbox is really horrible. Yes? Does this resonate? Yes? People go, yeah. And then, to make things worse, on top of all this, when we said, hey, the idea is that we're going to get rid of the old stuff and do some new stuff, one architecture, well, no, actually, we're now using all of them. So you still have your traditional app, and then you've got monolith in a box, put a container in a container and put it on a server. Yes, and then you've got your microservices, which is at least a bit more like what we're trying to do. And then, of course, you've got the other stuff where we're even getting smaller than that, and we're getting down to micro frameworks, or of course serverless, or functions as a service, that stuff. Yeah? You're using all of these things, aren't we? As long as it runs on cloud. Okay. So, we've gone from a little simple promise to something more sophisticated because we've realized that it's not as easy as we first thought. And we're making more use of these architectures because they're all valuable. And then we get to the next level, which is, where do you run all this stuff? Well, it turns out that when you go from one monolith to a load of microservices, your order of magnitude scaling, 1, 2, 3 order, needs industrial. And of course, the industrial thing that we use is Kubernetes. How many people here have a Kubernetes cluster? Oh, good. So not many of you. So there's lots of people who didn't put their hands up, which I think is a good sign. Maybe you'll walk away from here going, we're never going to do that. Okay. Right, so we have Kubernetes. At least we've got, that's okay, isn't it? So what tools do you have to deal with this level of complexity? Okay, you've put your foot into this puddle and you realize it doesn't actually have a bottom. What are the tools available to you? Okay, when I try something new, one of the things I'll do is I'll go Google for what are the top tools that I need for something. And normally if you said whatever it was, you'd end up with top 5 or maybe top 3 tools that you must know. And when I started doing this, I did Google this and I hit this one. Top 50 useful Kubernetes tools. And I got this, and I went through, and I went, yep, I understand why I need all of those. And if you look at the tool space in this area, now those of you that have done Kubernetes will have seen this before, and those of you who haven't, welcome. We'll talk about where this comes from later on, when we talk about the good side of all this. But what I'm trying to lay out here is containers are forcing us down this path because of the business promise, which we can't escape from. We are going down this road, okay? But it's good to keep your eyes open about what's going on and why we're here. And it is expanding much faster than we expected. And it's not just on like Kubernetes. So this is what's happening else in your building things. So if you're doing highly available systems, right? You don't want to have a single server ever that fails, because it isn't just about your production system standing up, it's about your development process able to deliver on a continuous basis, because that's part of the argument. So what does that mean? It means you don't want to have a single server. So if you're used to having a big Jenkins server with lots of jobs running, that's not how we do it. In a Kubernetes world, we use other technologies, And again, I'll mention these later on, but primarily what happens is we get away from having central servers to having pipelines. So every single deployment that you do, you'll end up having basically a Kubernetes operator or something similar that's designed to deploy your thing, whether it's a microservice or something bigger. So it's changing. Everything that you're used to is changing. And even the platforms themselves, even if you're not doing Kubernetes, right? Even if you're just doing Linux, then the world is changing there because containers are such a great idea that the immutability, rescalability of the stuff is pushing down. So even the operating systems that you're going to be using are going to be becoming containerized. So if you're using, well, I think it's Fedora 30, I think it's the core OS stuff, what's happening there is that you don't create a machine and then use Ansible or Chef or Puppet to configure. You set up a list of containers that you expect to have to run, and the machine installs these for itself, and then you have a running system. So containers are everywhere, right? So we thought this would make life easier for us, but actually right now it's made things much more complicated. And it's everywhere, right? If you ask people, pretty much everybody's using Docker containers, even if they don't have a Kubernetes, even if they're just pushing it to a large Docker machine, containers are everywhere, okay? It's everywhere. The problem is, apart from the complexity itself, now it's getting in the way, and we're seeing the businesses starting to say, hey, we can't manage this. The ops teams can't keep up. So you'll find lots of large companies are making some quite hard choices, and they're giving up, and they're drawing new lines. So whereas we talked about DevOps being this thing between the two teams of DevOps and ops teams, lots of people are going, nope, the world is Kubernetes cluster run by the ops team. Everything else is your problem. Everything else is your problem, right? However you do, whatever you do for DevOps, right, whatever architecture choices you make, the security, the whole works. It's your problem now. You know that interesting statement, you know, there's this Chinese proverb, well, it's supposed to be Chinese proverb, which says, may you live in interesting times, which obviously is meant to be a curse. So this is a bit longer than that, but this is our one. The container space is really exciting, and it's hard to keep up with the amount of new and exciting projects that appear every month. Welcome to the world of containers, right? So that lovely picture that you've seen, no, it's still our problem. You've all gone quiet. No, he's moving. It's a bit of a shock. And the thing is, if you're practitioners as developers, you will be doing this stuff and you're going, this is really horrible, okay? I'm having to do stuff that I wasn't expecting. So it's a bit not what we promised. Okay, so that's where we are. Containers have got us to this strange, interesting place where things are a lot more complicated and aren't as nice as we want. But the good news is there's a whole bunch of stuff happening that's going to make life easier for us. So, the question is, how do you refactor and re-engineer everything you've got? We can't take time out. We can't turn the internet off. We can't say, hey, give us a couple of years and we'll build some new stuff and then you can all use it. That's not what happens. So what's actually happening is all the tools are evolving as we go, which is why you see some such weird things. How many people here? Okay, so I asked, you weren't Kubernetes guys, but for those guys that are using Kubernetes, you know about kubectl, don't you? Yes, it's a wonderful tool. Who likes YAML? Okay, that's the right answer, yes. YAML. YAML is, what's happening is we are losing out on the usability. So lots of this stuff is happening. We are building quite complicated tools to deal with quite complicated problems, okay? And we are here.
Question.
Yes?
The machine in the left picture, what does it do?
Okay, so this is a machine that apparently, these are jet engines designed to put out apparently nuclear fires, yes, but it's actually being used to put out oil rig fires. It was somebody came up and said, we need a really, really big fire engine, and so that's what they've done. I think it's Russian, I think. But anyway, my point is, somebody put together something that you might think was inappropriately complicated for a very good reason. We just wish we didn't have the reason in the first place. Yeah? Okay, so what I'm trying to lead up to is, those of you that look at all this that's going on in the container space and go, this is really, it's not just you, okay? Please don't feel that you're missing out, that there's some magic going on. Where we are in terms of our development life cycle, where technology is going in this space, it's all brand new, it's all evolving, we're all looking at different directions. It's not you, it's everything. Okay? So containers got us here. Let's talk about what they're going to do to get us out. So I'm going to talk through the platforms, which is the Kubernetes space, okay, the Docker space, then the runtimes, which is the JVM stuff, and then the developer experience, which is the next layer up, okay, if I have time. We'll see how it goes. Okay, so the platforms. Right, so the first thing to take away is containers are not just Docker. Docker is primarily the container that you think about and you use, but there are more ways of doing containers than Docker. And the project that you want to go look at is a thing called the Moby project. The Moby project is a fantastic place where the technologies that are inside containers, or the technologies that give us containers, create containers, deploy containers, scale containers, are all evolving. It's not the only place, but it's a big place. Okay? And what's coming out of this, if you think Docker was cool, there's some promise of some really cool stuff coming. So the Moby project isn't a project that you would go use as a developer unless you're in containerized development space. But it's taken all the stuff that we use and it's carved them and architected them and created nice packages. And there are a whole bunch of projects, and I'll talk about a few of them. You're already using this because it's Docker. So Docker, I'm not saying got containerized, but got architected, and things got broken together, and lines were drawn, and so we now have some really wonderful architecture and some really great ideas and tools. Okay, and it's not Docker versus Kubernetes, it's Docker and Kubernetes. There's a whole bunch of commonality here. As you imagine, you can't have one without the other, really. So if you look into this space, this is what you see. Another big set of diagrams. Okay, but you can see platforms at the top, as in clouds, and you've got hardware down the bottom. Look, you've got ARM and Intel and others. Containers have to deal with different architectures, so it's not just x86 stuff. And there's a bunch of other stuff in there. The container D is the first thing to think about. This is the core. So if you're interested in where things are going, look at what happens in the Container D project. That's the one that's trying to create literally that platform for the future. And I talked earlier about Linux becoming containerized. Well, it's going to be based on these sorts of core technologies. Okay, so we won't go into the details because it's not particularly relevant. But it's Container D is something to keep your eye on to understand. That's the core, right? And then there are a few other projects in the Moby that are worth talking out. So Infrakit is really cool. Infrakit is the bootstrapper, the installer. You use this already, but you won't know about it. And you can see probably a list of some of the plugins and some of the target platforms that they enable, the different clouds. That's fine. I wanted to point out there's a couple of other things that are in there that you don't see yet. So like GPU cluster provisioning, that's a different thing that has to happen. It's important, it's part of the project. And the day-end stuff is that repeatability of how do you get things, the next version and stuff installed, okay? So you can see there is lots of good sense going on, and though it's coming out at the top in sometimes we get very confused, actually there's some really good engineering going on to give us this platform. We're just pushing it underneath what's happening. And then there's build kit. You're already using this. This is what Docker uses. When you do Dockerfile to the source, Dockerfile to image, that's what build kit does. That uses a thing called LLD, which is the technology that basically does the heavy lifting. It does things that Docker files don't have yet. Right? I put it in quotes because it's from their website. So things like executing without root privileges. That would be cool, wouldn't it? Having Docker containers that you could, containers that you could run that doesn't require root access. Doesn't require you having a daemon running in your system that runs under root. That's where it's coming from, okay? You will see over time more things turning up to allow us to create containers that aren't Dockerfile oriented. There's still very much the sort of the rules of physics about how this stuff is created is going to stay the same, but lots of the ways that we build Docker containers are going to morph and give you more capabilities. Okay, unless you're in this space, you're not going to get much out of this other than just being curious. Looking at the Moby project and seeing what they're doing at a high level is a good indicator of where things are going. It's not the only place that good news is happening. So I would encourage you all, whether you're into this or not, to go and have a look at the CNCF, the Cloud Native Computing Foundation. So this is the umbrella project, lots of projects. You see all those tools? Well, what they're doing, among other things, is trying to give us some roadmaps, to give us some sanity about what needs to happen next, in what order, so that we did get away from this sense that there are 50,000 tools you have to use, down to something that says, no, we have plans. And they're working with all the different projects and companies, everybody's involved in this space, to try and give everybody that sense. Okay. So I would totally encourage you to just have CNCF as a page you go visit and sign up and just see what's going on, because it will tell you where things are going. Okay, so that's the platform. That was just a much of, look, there is order and there is a few cool things happening, and the important thing to remember is containers do not equal Docker. Right, let's move up a level. Runtimes. Who's got Java? Okay, I've got to do this. Who uses Java 8? Okay, and who uses Java 11? Anybody use anything higher than 11? Any daring souls? One, maybe two. Okay, cool. So you use Java. Let's talk about some stuff. So this is these are the types of architecture. Some of the types of architectures that we are trying to build using containers. And as Java developers, that means with Java. So if you take a squint at this, you can characterize basically the both ends of this spectrum. Right? And if you think about it, you could name these things already. So you've got long-running, large applications, loads of threads, very large heap, 1, 2, 3, 10 of them. That's big systems. And of course, at the other end, you've got the tiny ones, the microservices, even the functions as a service, tiny footprint, don't live very long. Single-digit threads. It's just single-digit threads. They're meant to be one line, not single-digit and threads. Low cost, low cost, but thousands of them. Now, we have tuned JVMs to this side for all the time that I've been doing Java. And it's only recently that we're beginning to explore this space. Okay. Now, before I go any further with this conversation, I just need to level set so people understand a little bit about some of the rules of physics. So here's a nice diagram, which means very little. You've got time, and you've got throughput, which could be also CPU usage. Okay. And the red line is the throughput of your application. Okay? Now, as you start an application, over time, the JITs kick in, and they use your time and effort, your CPU, to move that red line up. Throughput goes up because the JIT gets involved and figures out what your code's doing, turns it into machine code, may re-optimize, a whole bunch of stuff, okay? And so basically, the economics say that the time that it takes, this length of time to get the red line near the top, is well worth it, because the CPU that's not part of the throughput is being used, where am I? This bit is being used to create all the necessary compiled code so that you can actually hit the top line, okay? That makes perfect sense. And then what happens is, when we say, okay, it's a tiny application, it's not going to live very long, and we cut it off really soon, then basically we don't get the throughput because we haven't spent long enough jitting it, right? That's the basic fundamental problem that we have. And we have this problem because of containers and because of the architectures that we've decided we want to build with those containers, okay? So, we have these two performance arcs. We have the one with the bump, which is the traditional performance thing for monolithic type long-running applications, where we're willing to take time to reach the throughput that we want, and we're willing to spend, like the bump, is his extra memory that we'll use to get the application up and running, right? That's what we do. That's a traditional pattern. What we're trying to switch it to is one where we go from nothing to full throughput as quickly as possible, or as ideally straight up, and with no extra costs like memory costs and things, because in a cloud environment, that's going to pay for it. And you don't want to pay, in the worst case, you don't want to be in a situation where you're moving from one tier to another in Amazon or whatever, just so that you can start your application, but you won't need that extra for running it. So we don't want the bumps, okay? So, what are we doing? So here we are with this new thing that containers are driving us towards. And so we're now looking at what we can do to deliver, okay? So I have a bunch of arrows and a bunch of things. So characteristically, we're going to JIT differently. We'll talk about what that means. Well, if we have less C code and more Java code, perhaps we could JIT that quicker. Because moving from Java to C is expensive, and that hits throughput, okay? We'll retune the JIT and the GC. Yeah, we can do that, because the way that the JITs work, the way that the GC work, is all heuristically driven by the workloads. So we can look at new ways of doing that. We can take a much better look at the memory allocation usage we've got, so we can reduce the memory. We didn't care too much because we were running on big systems, so a little bit wasn't a big problem. Now maybe it is, right? And opportunities for sharing. So what can we do to make use of this investment in JITting things so that we can reuse it somewhere else? And other ideas that we have for sharing, okay? And then container awareness. Well, it turns out that actually, unless you tell a VM that it's running inside a container, it doesn't always spot that. And that was a bit of a problem to start off with, okay? So, here's what's happening. We're looking at the balancing act between JIT compilation and ahead-of-time compilation. And we're starting to say, so what's the pros and cons? Where, as you can see, there's no point going to the table, but you can see things that we've identified, like speculative optimization, which is the one that says, we'll guess what you're going to do, because if we're right, we win, and we'll get better at guessing. And of course, if you're doing AOT compilation, there's no speculative optimization, there's just one go. Ahead-of-time compilation doesn't know what your application's going to do, but JITs do. So if we take the guessing and that information out of the system, then what happens? Well, your application will probably be slower, right? So we're looking at this, and you may not be aware of this, but there are some big challenges in taking Java from the old way of doing things towards the new way of doing things and taking your applications along for the way. Okay? Because we have this thing called the spec, the Jvm specification. It's the thing that means we can have all the different Jvm implementations and people are all happy that it works. It's the spec that tells us what we're allowed to do in terms of turning the Jvm into machine code to put into that container for you. Okay. So currently we are hampered by the specification because it's already made some decisions a long time ago about the operating environment. And now that we have containers, we have a different operating environment, a different thought process, and it's driving us to look differently at how we do JVMs. I told you, containers are changing everything. Right, so what's happening? Well, let's look at 4 of these things. And I know you're all going, what's the last one? Well, we'll come to the last one. So, what's already happening? Hotspot. JDK 10, we put in container awareness. Great. We've put the JDK 13, got more capabilities for sharing. I told you one of the things we should do is figure out, let's not keep recompiling it. And if you use the class loading facilities, you can now take your cache classes from one execution, bake them into your Docker container, and share them with another instance. And if you're not doing that already, you should take a good look at that, because that can help reduce startup time and make your image a bit bigger, but what the hell, right? So that has come out of those things. So that's great. We've got more opportunities for sharing, and we started in Hotspot's got the right stuff in to understand that it's running in a Docker container. The reason this is important is Docker containers tend to be restricted, and if you're not aware of the restriction, like number of CPUs, memory or whatever, what happens is the JIT goes, or the JVM goes, oh, you've got 200 gig of memory. I'll use that. Or you've got 50,000 CPUs. I'll use that, even if your container has been designed not to do that. So that's what that's for. So that's cool. And then more, we've got Graal. So JDK 9, they put it in as a ahead-of-time compiler. So it's a new set of technologies looking at the old problems and trying different ways to get there, right? That came as a JIT. And then JDK 11 got a no GC. Now, people may go, hey, that's really silly. But if you have a very short-lived application, and I mean, milliseconds or whatever, or just a few seconds, it may make perfect sense not to spend any time doing garbage collection, because why would you if your application is finished before you do the first GC? So that's why it's in there, because we're exploring whether or not that will actually make much difference. Okay? So that's Hotspot. Now, I work for IBM, and one of the things that we've got, which we open sourced a couple of years ago, 3 years ago, was the Open J9 Jvm. Okay? That's a different code base from a different starting point. And so we're looking at the same problems. So it's got better sharing technology. Okay? It's also, and this is the good thing from a container point of view, already got built in much better memory footprint. Okay? It's got much better sharing because it shares code and class files. Okay? Think about sharing the binaries that you've curated, the machine code. So J9's got more capabilities, and it's got container awareness and stuff like that. And that's cool, right? So from this point of view, going back to that chart, what I get with, as a comparison, so the red line is Hotspot. Okay. So I would say this is not in any way having to go at Hotspot. This is saying, look, here's different ways of how we're implementing this stuff. If I go to Java 9, if I go to using OpenJ9, just out of the box, it's a steeper rise. So that means that we can start the application quicker. If we can start the application quicker, we can get the work done faster. Maybe we can terminate it quicker, right? And then, oops, that went the wrong way. Did you see? Okay. You can't see that one, can you? Well, that's really good. Okay, there's a really fantastic picture. I don't know where that's gone. Okay. I was going to show you what you could do with AOT, but we'll move on. What I'm trying to show you is, in the VM space, the same challenges that you're thinking of about how do I do these things are happening in the JVM space. And we are actively doing these things, okay? So there's a whole bunch of stuff going in this space. I don't know what happened there. Am I going backwards? I'm going backwards, aren't I? That's what the problem is. Okay. I've lost it completely. There we go. I'm just so excited. Okay. So this is AOT. This is this idea of let's take the jitted code and use it and store it and share it, okay? And that gives you those sorts of benefits, right? And that's the technology idea, not specifically any implementation. We're looking at how do you solve these problems and can we achieve it? That's cool, right? So what else are we exploring? I'm going the wrong way. I've got to learn to use this. So J9 as an instance is also looking at the idea of, well, let's take the jitted code and do no jitting in the application because that's your CPU. Maybe we can come up with a way that we can get your application to start up really quickly by taking the compilation step and putting it outside in a different server. Okay? Right. So the idea is if you have a bunch of serverless, little tiny microservices, don't spend any time jitting, push that to another service, because not only can it do it for you, it can also remember and cache them and do more optimization and try and give you higher throughput. So we're exploring that, okay? And that's working. For the right circumstances, we're reducing the memory consumption by sharing in this way, because we're not using memory to do jitting, right? And again, in the right circumstances, we can get massive improvements in throughput, right? But only for those tiny services that you're using because they're constrained. And in a constrained environment, things are much more expensive relatively. So by taking this stuff out, you can do it somewhere else. So this stuff is all really cool tech that we're exploring, right? And then you've got this thing. Who's heard of Graal? Okay. Who's heard of Quarkus? Even better. Who's used Quarkus? Okay. Okay, I thought at the moment there was more hands than the first one. Okay, so Graal is another JVM from a different angle that's coming together. Graal is looking, again, at these same questions. How do I JIT differently? Okay. Can I do more Java than C? Because if I can not cross the boundaries between Java and C code, and I stay in the Java space, then I can get the optimizations done differently, and I can reduce my performance costs. Okay, and they're looking at allowing different programming languages in, because one of the other things we're not clear on is, for in a container world, how much are we going to mix and match things inside the container versus having different parts of a microservice application being written in different programming languages? Don't know. Right? We're still trying this stuff out. Okay? And the Graal guys have done something very brave, because they've done what a lot of people have been talking about, is that they said, what happens if we ignore some of the limitations from the JVM spec that was designed for this original environment? Okay, so one of the things that you can see from Graal is that they've made some decisions, unilaterally of course, to try this stuff out, right? And it's working. These are benchmarks from their website, right? But you can see there's massive improvements by making some of these trade-offs, right? And a lot of this is native image, going straight from Java to machine code, and then running that. Is that the future of Java? Don't know, but we're looking at it. So one of the best things that's come out of all of this, all of what's happening in the container space, has been this thing. Not for the technology itself, but from the fact that it has made us think about the future of Java and has made people begin to understand that to move Java forward, we have to change things, and maybe radically. The difficulty for us in this space is how much you can change to get the benefits that we think you need versus the cost to you to move your application. Ideally, we'd like to have a solution where you get all the benefits that you need for serverless and all those sorts of things without having to change a piece of Java code. But there's no guarantee that will be the answer, because it may not. Okay? Right, so I said about the next one. So this is what's happening in the JVM space, but don't think that JVMs are the only place that this problem is being explored, or that there are not other technologies out there to help you do this. There's this thing called CRIU, and it's been around for a bit, and some people started playing with it. It's a Linux technology. It is what it says. Take a snapshot of a running container and put it down onto the disk, bed it into the container, and then have a different image that you can start off with that running image, and restart. Okay? CRIU is a technology that's also enabled in I think it's the Containerd or one of the sub-projects over in this container space, because it's not just a Java solution, it's something that could benefit anybody. Being able to take a running system, snapshot it, and then restart it later. So you want to see how much it makes a difference? So I have this test. Now, it's not particularly scientific. I have 3 Docker images, all doing pet clinic, and all it's going to do when I run it is it's just going to keep waiting until the home page pops up, and it's going to time it. And it's also going to tell us how much memory it used, as far as Docker was concerned, to get there. Okay? So this is a video, because I'm not doing the demo live. Been there. Okay, right, here we go. So get everything ready, kick it off, and then go. Ta-da! Whoa. Okay. And now you're waiting for the... How long is it going to take? How much slower is it going to be? Are we there yet? I've got 20 minutes. Keep going. Keep going. Ooh. Okay. Ooh. That was interesting. So let me just talk through what you saw. So the numbers are my timings on my machine, so they are not performance benchmarks, right? They're not meant to be, hey, this is far much faster than this one. They're close enough in this environment to go about the same. The memory usage is different, right, between these two, because J9 has just got a better memory story, all right? It was brought up that way, it was designed that way, and it comes out of the box. This one is CRIU tech. So we had this application, got to this point, snapshotted it, created a new image, and then fired that one up. So the 5 seconds that you see here is the time it took for obviously the container to start, but then for this memory update to happen to bring the system up. It's not trivial, but wow, does it go fast. It costs you a little bit more memory, but there we go. That's not JVM tech, right? It's an idea that's already in Linux, right? And why are we doing that? Because we can, because it's containers. Containers are changing everything. Right, so last one, developer experience. This is an interesting one, because of all of the stuff that's happening, this is the one that probably we'd go, not much really. There's a couple of bits. So, what are containers doing to your life? Well, we already talked about, I mentioned this one. And it's another sub-project that you might want to go look at. This is on a Linux Foundation, the CD Foundation. As I said to you, when you're doing Kubernetes, there is this complete desire not to have central servers, and the build environment, the CI/CD stuff, is now much more pipelined, as they call them. And Tecton is the base tech, or at least a set of base tech. And then Jenkins X is, as you'd expect, something like the same thing with more of what you'd expect to have in it to produce a build system and to do all the beginnings of all the things that you want to do. A lot of this is still early days, but I really suggest you go have a look at it and start to think about how much or how little it will do for you compared to what you currently have if you're using Jenkins or whatever, right? Because this is where everything's going, because one of the other things that's happening in the Kubernetes space is this thing called operators. And this is the idea that you have code logic running in the cluster that will do things for you, and you can't work around them. They might be security policies, they may be deployment technologies. It'll make your life easier, but it will constrain you. So you will find that people will be providing technologies and an operator, and that operator may have one of these pipelines built in as the way to make things happen. So this is technology that you need to start getting your head around, because at some point you probably won't be able to avoid it. So that's robust. We know this is happening. There's a bunch of people doing this. The Jenkins X, the Cloud Big Guys, everybody's looking at that. It's their space. Yeah. So let's go back to remember this. Your local environment, yes. So we have this problem that we've created ourselves because of containers, because of the fact that what you've got on one side and what you've got on the other side doesn't necessarily miss up. So what's going on? Well, there's something you could do to make the mismatch disappear, is you could put Kubernetes on your desktop. Anybody tried that? Anybody hate the idea? Yes. So for those of you who haven't tried it, when you get to the point where you've installed Kubernetes on your desktop, you will understand why everybody goes sigh, right? It's because if you've got a fan, it will come on and it will never go off, even if you're doing nothing, because it's not great on your desktop. So asking developers to run Kubernetes on the desktop so that they can get an environment that matches the production system is probably not a good idea. Okay. So what else is going on? Well, there are people saying, why don't we move your development into the cloud and then create some plugins in your IDE so that your IDE, you yourself think that what you're working on is local, but actually the source code and the build, your local environment is actually sitting in the cloud. Okay? And if you use VS Code, for instance, there's already a remote editor plugin that will let you seamlessly have that experience. So then if you're in the cloud, you're running on a Kubernetes environment, then you've got slightly better chance of having a reproducible environment to match your production system, right? And we're playing around with that, right? Then there's cloud-based editors, which is where you put the whole of everything, including the editor, into the cloud, and you access it through your browser. Who here would like to give up? So who uses IntelliJ? Okay. Okay, how many would you like to give up? Would you like to give up IntelliJ? No? Hey, one, thank you. Yeah, okay. Well, it might be something you have to consider. Right? Now, the advantage of putting it in the browser is you don't need all this stuff, right? So your business will love that because that means they'd have to buy you a shiny big laptop. You'll be working on Chromebooks before you know it, right? But it's a serious thing. What we're looking at is what can we do to make the developer experience better, but deal with this problem that containers have created for us, is that getting this environment locally is turning out to be really difficult, okay? Because you don't want Kubernetes because it doesn't perform well, but on the other hand, you need Kubernetes to have the local environment to match, assuming that you can even build the level of sophisticated test environment that you need to match what's happening in Kubernetes, because you've got 10,000 services running and data and all that sort of stuff, okay? So, the other thing that people are looking at are what can we do maybe to reduce some of the mismatches? So part of the conversation is about the build tools that you're going to use and how they're all different, even though they're the same. As in, I've got this version of Java and I'm building on Mac, and the build tools, this version of Java, very much the same, but working on Linux or whatever, and you get differences. So one of the things is, can I take their build tools, put them in a container, and push them down to the development team, and have the same build tools in a container, and integrate them into the IDE, so that you still get the IDE experience that you expect, but you're not relying on local build tools, you're relying on ones that come with a container, okay? And so Codewind, Eclipse Codewind, is a project that's exploring that space, right? So, cloud IDEs. It's all about, can we get the parity, the disparance between what you as a developer have, because you need to be able to be productive, but also need to be able to make sure that you don't ship stuff that doesn't work in the cloud, right? Right. So can you run something like your production locally, right? Or do we move the development to the cloud? These are the two ends of the spectrum. Both of these ends are being explored, right? There's a bunch of people out there in this space. And this has all been driven because of containers. But on the other hand, the good news is this is all containerized solutions. We are looking at using containers to attack the problem and put stuff into containers because of the immutability and reliability that we had at the beginning. Okay? So it's clear we have to do something, because otherwise development life gets really horrible. Yeah? But then again, we did ask for this. We did ask for cloud. Okay. Thank you. That's it.
Thank you, Steve.
Wow, look at that. I want to show you another page, which I can't show you because it's not there. Just to let you know that apparently at about 3 o'clock or 3:30 today, I'm doing a book signing with Pratik Patel, who is a co-author of a microservices book we did. We haven't got many copies, so if you're interested, come to the IBM booth early and we'll give you a copy. Other than that, I have time for questions?
No, unfortunately not,
No?
because it's time for lunch.
Oh, sorry, I have to overrun. My apologies. If I have you only questions for me, come find me. I'm around all day, all week. I'm at the booth, knocking around. Thank you very much.
Thanks a lot, Steve.